You've never touched anything. Not once in your entire life. Right now, you think you're sitting on a chair. You're not. You're hovering above it, suspended by electromagnetic forces. The atoms in your body and the atoms in the chair are repelling each other. They never make contact. There's always a gap. Always empty space between you and everything you think you're touching. The floor beneath your feet. The phone in your hand. The clothes on your body. You've never actually touched any of it. And it gets stranger. The atoms themselves, the building blocks of everything you see, are almost entirely empty space. If an atom were the size of a football stadium, the nucleus would be a marble at the center, and the electrons, tiny specks orbiting somewhere in the upper seats. Everything else, nothing. Empty space. You are 99.9999999% empty space. The chair is empty space. This room is empty space. The entire universe is almost entirely nothing. And yet it feels solid. It looks solid. Einstein understood why. And what he discovered challenges everything you think you know about reality. Because solid isn't real. Mass isn't what you think. And the physical world is nothing like it appears to be. Let's start with what you think you know. Matter is made of atoms. Atoms are made of protons, neutrons, and electrons. Protons and neutrons are in the nucleus. Electrons orbit around it. Simple. Except none of that is accurate. Electrons don't orbit like planets. They exist in probability clouds. They're not in a specific place until you measure them. They're smeared out across space, existing everywhere and nowhere simultaneously. And protons and neutrons, they're not solid either. They're made of quarks, and quarks are held together by gluons. And both quarks and gluons are excitations in quantum fields. They're not particles in the traditional sense. They're ripples in invisible fields that permeate all of space. So, when you go down to the fundamental level, there are no solid objects. There are no tiny billiard balls bouncing around. There are only fields, vibrating, interacting, creating patterns that we perceive as particles. And those patterns are mostly empty space. Now here's where Einstein comes in. He proved that matter and energy are the same thing, E equals mc squared. This isn't just a formula. It's a statement about the nature of reality. Matter is frozen energy, concentrated, localized, but still energy. And energy is not a substance. Energy is a property, a measure of the ability to cause change. So matter isn't made of stuff. It's made of relationships, interactions between fields. Einstein showed that mass, the thing you think of as the solid substance of an object, is actually the energy contained in the particle's field. A proton has mass, not because it's made of some dense material, but because the quarks inside it are bound together by gluons, and that binding energy is what we measure as mass. Most of the mass of a proton comes from the kinetic energy of the quarks moving around and the energy of the gluon field holding them together. The actual intrinsic mass of the quarks themselves is tiny. Almost all of your mass is pure energy, vibration, motion, not substance. So why does anything feel solid? Why can't you walk through walls? If everything is mostly empty space, if atoms are almost entirely nothing, why doesn't your hand pass right through this table? The answer is electromagnetic force. Specifically, the repulsion between electrons. When you push your hand against a table, the electrons in your hand get close to the electrons in the table. And electrons repel each other, strongly. This repulsion is so strong that it feels like a hard surface. But it's not contact, it's force. The electrons never touch. They can't touch. They're quantum objects existing in probability clouds. What you feel as solidity is actually repulsion. A force field pushing back against you. And this force is incredibly strong at small distances, which is why you can't compress solid objects much. The closer the atoms get, the stronger the repulsion, and it increases so rapidly that it becomes essentially impossible to push atoms together beyond a certain point. Before we go deeper, you need to understand something. This isn't abstract philosophy. This changes how you experience reality, and most people will never learn this. So subscribe to this channel right now. Hit that like button. Share this video with someone whose mind needs to be blown, because what's coming next is going to completely reshape how you see the physical world. Let's continue. Let's talk about the Pauli exclusion principle. This is a fundamental rule of quantum mechanics discovered by Wolfgang Pauli. It states that two identical fermions, particles like electrons, cannot occupy the same quantum state simultaneously. In simpler terms, two electrons can't be in the same place doing the same thing at the same time. This is why matter doesn't collapse. This is why you don't fall through the floor. The electrons in your feet and the electrons in the floor are fermions. They obey the exclusion principle. So when your feet get close to the floor, the electrons repel each other because they can't occupy the same space. This creates an upward force that balances gravity. You experience this as the floor being solid, but it's not solidity. It's quantum mechanical repulsion, a force arising from the fundamental rules of quantum fields. Without the exclusion principle, all matter would collapse into a point. Atoms wouldn't exist. Chemistry wouldn't exist. You wouldn't exist. The apparent solidity of matter is a quantum phenomenon. Now let's go deeper into what atoms actually are. You learned in school that atoms have a nucleus made of protons and neutrons, with electrons orbiting around. But this is a lie. A useful simplification, but fundamentally wrong. Electrons don't orbit. They exist in orbitals, which are probability distributions. An electron in an atom is smeared out in a cloud around the nucleus. It doesn't have a definite position. It has a probability of being found in different locations. And when you measure it, when you interact with it, the probability wave collapses, and the electron appears at a specific point. But before measurement, it's everywhere in the orbital simultaneously. This is not a limitation of our knowledge. This is the nature of reality. Electrons are fundamentally probabilistic. They exist in superposition, multiple states at once. And this is true for all quantum particles. They're not little balls. They're waves, fields, patterns of probability. And the solidity you experience is an emergent property of trillions of these probability patterns interacting. Einstein struggled with this. He famously said God does not play dice. He believed quantum mechanics was incomplete, that there had to be hidden variables determining the outcome, that particles really do have definite positions and we just don't know them. But experiments have proven him wrong on this. Bell's theorem and subsequent tests have shown that quantum mechanics is not hiding anything. The uncertainty is fundamental. Particles really are in superposition until measured. Einstein was right about relativity, right about mass-energy equivalence, right about spacetime, but wrong about quantum mechanics. And yet his work laid the foundation for understanding that matter isn't solid. Because if mass is energy, and energy is a property of fields, then there's no substance. Only parts. Only relationships. Only interactions between fields, creating the illusion of solidity. Here's something that will break your brain. Most of the mass in your body doesn't come from the particles themselves. It comes from the binding energy holding those particles together. A proton, for example, is made of 3 quarks. But if you add up the mass of those 3 quarks, you get less than 2% of the proton's mass. Where's the other 98%? It's the energy of the gluon field, the force holding the quarks together. That binding energy, through E equals mc squared, manifests as mass. So, when you step on a scale, you're not measuring the mass of particles. You're measuring the energy of force fields. You are not made of matter. You are made of energy in configurations that create apparent mass, and that energy is not stuff. It's activity, motion, vibration in quantum fields. You are a pattern of vibrations, a temporary configuration of energy. And so is everything else. Let me give you a specific example. A hydrogen atom, the simplest atom, one proton. One electron. The electron is about 100,000 times smaller than the atom, and the proton is about 100,000 times smaller than that. So, if the proton is 1 centimeter, the electron orbit is 1 kilometer away, and there's nothing in between. Just empty space, or is it? Quantum field theory says that empty space is not empty. It's seething with virtual particles. Particle-antiparticle pairs popping into existence and annihilating constantly. The vacuum is alive with activity. And this activity affects the electron. It creates a phenomenon called vacuum polarization. Virtual particles appear around the electron, screen its charge slightly, and affect how it interacts with the proton. So, even the empty space inside an atom is not really empty. It's full of quantum fluctuations. And those fluctuations are real. They have measurable effects. So, when I say atoms are mostly empty space, I need to qualify that. They're mostly empty of permanent particles. But they're full of temporary quantum activity. The vacuum is not nothing. It's a bubbling sea of potential. Now, let's talk about what this means for you, for your daily experience. You walk across a room. You feel your feet hitting the floor. Solid. Real. But what's actually happening? The electromagnetic fields of the electrons in your feet are repelling the electromagnetic fields of the electrons in the floor. The force of this repulsion equals your weight, so you don't fall through. But you're not touching the floor. You're hovering, suspended by quantum forces. And every step you take is a dance of fields interacting, never making contact, always separated by infinitesimal gaps. And your brain interprets this as solidity, as walking, as touching, but it's an illusion. A necessary illusion. Because if your brain showed you reality as it actually is, a swarm of probability clouds repelling each other through empty space, you couldn't function. You couldn't navigate the world. So your brain creates a simplified model, solid objects, hard surfaces, simple mechanics, and live in that model, never seeing what's really there. We've reached the halfway point, and I need you to really absorb this. Everything you think is real is a construct, a model your brain creates from quantum interactions. Subscribe to this channel if you want to keep peeling back the layers. Hit that like button, share this with everyone. Because once you see through the illusion, you can never unsee it. And that's exactly where we're going next. Let's continue. Let's talk about why this matters. Why should you care that solid objects aren't solid? Because it changes how you relate to the physical world. When you understand that matter is mostly empty space, that atoms are probability clouds, that forces create the illusion of solidity, you start to see through the appearance. You realize that the boundaries you perceive are not absolute. They're conventions, useful fictions. The boundary between your body and the air is not a hard line. It's a gradual transition. Atoms from the air are constantly entering your body. Atoms from your body are constantly leaving. You are not a closed system. You are a process, an open flow of matter and energy. And the matter isn't even really matter. It's vibrations in fields, patterns that persist for a while and then dissipate. You are not a solid object. You are a dynamic pattern, a wave passing through the ocean of quantum fields. Here's another example: diamond, the hardest natural material. You think of it as solid, permanent, but it's just carbon atoms arranged in a specific lattice. And those carbon atoms are mostly empty space. The electrons in the carbon atoms create strong covalent bonds with neighboring atoms. These bonds resist deformation, which is why diamond is hard. But the hardness is not intrinsic to the atoms. It's a property of the arrangement, of the geometry, of how the electromagnetic forces interact when you try to push atoms out of alignment. Change the arrangement, and the properties change completely. Graphite is also pure carbon, but arranged differently. And it's soft, slippery, the same atoms, the same electrons, but different configuration, different emergent properties. So hardness isn't a property of matter itself. It's a property of how matter is organized. And that organization is temporary. Diamonds can be crushed, vaporized, transformed. Nothing is permanent. Nothing is truly solid. Everything is in flux. Now, let's talk about practical applications. Understanding that matter is mostly empty space has led to technologies that shape modern life. Nuclear power works because we can split atoms. If atoms were solid, indivisible units, we couldn't do this. But they're not. They're structures held together by forces. And we can break those forces, release the binding energy, and get enormous amounts of power. Semiconductors work because we can control the flow of electrons through materials. If electrons were solid particles orbiting in fixed paths, we couldn't do this. But they're waves, probability distributions. And we can manipulate those distributions with electric fields, create transistors, computer chips. The entire digital revolution is built on quantum mechanics, on the understanding that matter is not solid, that it's fields and probabilities, and we can engineer those at the atomic level. Medical imaging is another example. MRI machines work by manipulating the quantum spin of hydrogen atoms in your body. They apply magnetic fields that flip the spins. And when the spins relax back, they emit radio waves. Those waves are detected and turned into images. This only works because atoms are quantum objects, because they have properties like spin that don't exist in classical physics. If matter were solid in the classical sense, we couldn't see inside the human body without cutting it open. But because matter is quantum, because it's mostly empty space with particles that have wave properties, we can probe it with fields and get detailed images, saving countless lives. All because Einstein and others figured out that solid isn't real, that matter is energy, that the classical picture of atoms is wrong. Let's go even deeper. Quantum tunneling. This is a phenomenon where particles pass through barriers that classical physics says they shouldn't be able to cross. How? Because particles are waves, and waves can extend beyond barriers. There's a small probability that a particle on one side of a barrier can appear on the other side, without ever having the energy to climb over. This sounds impossible, but it happens constantly. In fact, the sun works because of quantum tunneling. The temperature at the core of the sun is not high enough for hydrogen nuclei to overcome their electromagnetic repulsion and fuse. But they tunnel through the barrier, and fusion happens. Without tunneling, the sun wouldn't shine, stars wouldn't exist, and neither would we. So the fact that matter isn't solid, that particles are probability waves that can tunnel through barriers. This is not abstract. This is why you're alive. Here's something else. Quantum entanglement. Two particles can become correlated in such a way that measuring one instantly affects the other, no matter how far apart they are. This violates our intuition about solid, separate objects. If particles were classical billiard balls, they couldn't stay connected across space. But they're not billiard balls. They're excitations in quantum fields. And those fields are everywhere, always. So particles can be entangled because they're not really separate. They're part of the same underlying field. And measurements on one affect the field in ways that show up in measurements on the other. This is not magic. This is the consequence of matter being field-based rather than substance-based. And it's been verified in thousands of experiments. Quantum computers are being built on this principle, using entanglement to perform calculations that classical computers can't, all because matter isn't what we thought it was. Now, let's talk about the philosophical implications. If solid objects aren't solid, if matter is mostly empty space, if atoms are probability clouds, then what is real? What can you trust? The answer is your experience is real. But it's not a direct representation of underlying reality. It's a model, a simulation your brain constructs. And that model is useful. It helps you survive. It helps you navigate the world. But it's not truth. The truth is stranger, more beautiful, more incomprehensibly weird than the model. And once you know this, once you see through the illusion, you gain something, not certainty, but humility, an appreciation for how little we actually understand, and a sense of wonder. Because the universe is not the dead, mechanical place it appears to be. It's a living, breathing, quantum dance of fields and probabilities and emergent patterns, and you are part of that dance. Let me give you one more practical example. Chemistry. All of chemistry is about electrons. How they create molecules, and electrons are not solid particles. They're waves, probability distributions. So when two atoms bond, what's really happening is their electron clouds overlap and create a lower energy configuration. The electrons become shared between the atoms. They exist in both places simultaneously. This is only possible because electrons are not localized particles. They're spread out. And when they spread out in the right way, they create stable molecules. Water, DNA, proteins, everything that makes life possible. All of it depends on the quantum nature of electrons. On the fact that matter isn't solid. If atoms were classical, chemistry wouldn't work. Molecules wouldn't form. Life wouldn't exist. So you owe your existence to the fact that solid objects aren't solid. Here's where Einstein's insight becomes crucial. He showed that space and time are not separate. They're unified into space-time, and matter doesn't exist in space-time. Matter is a curvature of space-time, a concentration of energy that warps the geometry around it. So when you ask what matter is made of, the answer is not some substance. The answer is geometry, curvature, pattern. Matter is how space-time bends. And that bending creates effects we interpret as mass, as solidity, as physical objects. But fundamentally, there are no objects. There's only space-time and its curvature. And the patterns in that curvature that we call particles, atoms, molecules, people. We are geometrical patterns in the fabric of reality. Not things, not substances, patterns. And patterns can change, can flow, can dissolve. Nothing is permanent. Nothing is solid. Everything is process. So what should you do with this knowledge? How does it change your life? First, it makes you less attached to material things. When you understand that objects aren't solid, that they're temporary patterns, you stop clinging to them. You appreciate them while they last, but you don't confuse them with reality. Second, it makes you more aware of interconnection. If matter is fields, and fields extend everywhere, then everything is connected. You're not separate from the world around you. You're part of it, intimately, inseparably, Third, it makes you humble. Because if the physical world is so different from how it appears, what else are you wrong about? What other illusions are you living in? And that humility opens you to learning, to growth, to seeing things as they are rather than as you assume them to be. Let me close with this. Right now, you're reading these words or hearing them, and you think the screen or the device is solid, real, but it's not. It's a pattern of atoms, and those atoms are probability clouds, mostly empty space, held together by electromagnetic forces, creating the appearance of solidity. But underneath, it's fields, vibrations, energy, and that energy is you too. You're reading this with eyes made of the same quantum fields, a brain constructed from the same probabilistic particles. You are not separate from what you're observing. You're part of the same system, the same dance. And Einstein showed us this. Not completely, not all at once, but he opened the door. He proved that mass is energy, that matter is not substance. And quantum mechanics completed the picture, showed that energy is fields, that particles are probabilities, that solid is an illusion. And now you know, you've seen through the appearance. And you can never go back to thinking the world is solid again. Welcome to reality. It's stranger than you imagined, and far more beautiful. If this video transformed how you see the physical world, then you need to take action. Subscribe to this channel right now. Hit that like button. Share this video with everyone who still thinks reality is what it appears to be, because this knowledge changes lives, it opens minds, it reveals truth. And I'm going to keep bringing you more insights like this, more deep dives into the nature of reality, more revelations that challenge everything you thought you knew. So subscribe, share, and I'll see you in the next video where we'll explore even deeper mysteries of existence.